Right, in today's class we will see the some more instructions, right? That is data transfer instructions. First one is what? Data transfer instructions. Right. Second one is data compare instructions. And third one is the arithmetic instructions, right? Instructions, right? One by one we'll see. So how this particular data transfers instructions are adjusted in PLC ladder logic, and similar way data compare and arithmetic instructions also, right? We'll see. First one is data transfer instructions, right? So previously in ladder logic, that means in ladder programming, right, we have discussed so many types of instructions using normally rungs, that means coils and contacts. And apart from that, we have discussed some box format also. Box format, what is the use of box format? Right, in the box format we have a rungs to perform timer and counter operations, right? In the similar way we discussed in the rungs format, in rungs way we discussed some master control reset instruction, jump instruction, like that also, right? So here these all instructions, whether it's data transfer instruction or data compare instruction or arithmetic instructions, right? Arithmetic instruction means in arithmetic instruction you are going to get the addition, subtraction, multiplication, division and square root instructions, right? All instructions, these three types of instructions are normally going to be adjusted as a box format in rungs, right? We'll see one by one what are the instructions are going to be adjusted in these three types, right? In these three types. First one is what? Data transfer instruction. First one is what? Data transfer instruction. What are the different types of data transfer instructions are there, right? Where this particular data transfer instruction come into the picture, right? So normally in PLC we have, right, RAM, right? For example, this is the RAM. This is the RAM we have in PLC. Alright, so this RAM as a some number of registers, depending upon the strength of RAM we are going to use in the PLC, right? So these particular registers are going to be adjusted, right? So number of registers are going to be adjusted. Alright, so normally these registers we are going to be named as holding register. Holding register 00, for example 202, for example holding register, I just given name 900H, right? We have a registers below this one as well as above that one, above 900 register we have a some bunch of register depending upon the RAM, how much RAM we have in that particular PLC, right? So all registers, what is the use of all registers? All registers are used to store the data, user data, input data, or updated with output data after completion of some operation in the PLC, or used to store the PLC ladder logic programming. Ladder logic programming equivalent binary code in this particular memory, right? So that is all not our intention at this point of time, right? Here is what, sometimes if you need to transfer the data from one register to another register, and one register to another register, for example this register to this register, or somewhere from this particular register to this particular register, right? So like that register to register data transfers will take place, right? In the similar way sometimes more than two register data, right? Some group of register data you want to move to the some group of sequential locations, right? So this is the register to register transfers may takes place, right? Second one is block of register data to block of register data, right? More than one register data if you want to move from one location to another location, that is some bunch of register data is going to be moved to the some other bunch of register data. And third case, sometimes as some table of registers, for example some 10 register table, data. If you want to move to the one register, right, that is going to call as a table to register transfer. Register transfer. And fourth case is register to table. Register to table, right? So like that, these are four possible ways of data transfer will takes place from one location to another location, right? So sometimes register to register data transfer is required. Sometimes more than 2 register data is going to be moved to the more than 2 register sequential location. Sometimes some table of 10 register data sequentially for every one step, one by one register data is going to be moved to the destination register. Fourth case is one register data is going to be moved to the sequential locations in the table, right? So these are the 4 possible combination of data transfers will takes place in PLC, right? To perform this particular 4 possible transfers of data transfer, we have a instructions in the PLC, right? One by one we'll see how data transfer will takes place from register to register. That means to transfer the data from one register to another register, how this particular rung is going to be adjusted. Rung is going to be adjusted. That means PLC logic is going to be adjusted. You can see here, register to register transfer. First one is what? Register to register transfer. Register transfer, right? Register to register transfer, right? So for doing this particular one register to, for example, this one is the holding register 0021, right? So if you want to move to this one data to the holding register 24, right? So this is the way if you want to move the data, how you can move the data, right? So to perform that particular one, we need to write an instruction like this in PLC logic, right? In the PLC logic, we are going to write like this: logic for this particular data transfer. So this is the rung, right? We already know that this is a positive rail, this one is the negative rail, right? So this is the box format we have in this particular rung to transfer the data from one register to another register, right? So this, in this block we have a 2 addresses, that is the source register, right, and another one is a destination register, right? So here we need to give name. This source register is what? Holding register 0020. In the similar way, here destination register holding register 0024. For example, if you want to move data from 0 to 4 like this, we need to write source register holding register 0020, destination register holding register 0024, right? So this operation is going to perform whenever you enable. This is the enable contact. For example, that is connected to I 0.1. Whenever this is high, this operation is going to takes place. What is this particular operation? Source data is going to move to the destination. Once it is moved, right, for moving we have a prefix like this, MV, move. We need to write prefix like this, MV, give some address Q 0.1. Whenever this transfer will, whenever you enable this particular input, right, data is going to be transferred from source register holding register 00202, right, destination register holding register 0024. Once data present in this particular register is transferred to this register, right, this output is going to be high, right? To perform this move operation, we need this particular prefix here. Code is here is what? MV. MV is the code to move the data from one register to another register. So this is the rung to move the data from one register to another register. right? So this is the one type of data transfer. And second instruction, if you see, right, second instruction, if you see, right, second one, what is the way of data transfer? The second way is what? Block to block transfer. Block to block transfer means what? So some memory locations present in the RAM, right, right. So these are the some set of locations in the RAM. Like this. For example, these are the 10 registers. These are the 10 source register data. You want to move to the some other 10 registers, destination registers, right? Ten other sequential 10 registers, 10 registers, right? So how many registers there are? These are 10 registers, right? So destination also we have a 10 registers, 10 destination registers, right? So you know this particular registers, for example, holding register 00402, like this, holding register 0049, right, 49, right? So in the similar way here also, if you look at this particular one, right, so this one is the holding register, for example, holding register 502, holding register 0059, for example. These are the 10 registers, these are the 10 registers, right, we have. So where these particular registers are going to present? In this particular RAM only, in this particular RAM only. Some sequential location here, holding register 00402 49 sequential 10 registers data. You want to move to the 10 sequential registers which are going to be addressed from holding register 0050 to 0059, right? So you want to move this 10 register data to this particular 10 registers, right? So to move the data like this, we need to write a rung, right? So for that, how we need to write a PLC logic? You can write a rung here. Second way is what? This is the block to block transfer, right? Block to block transfer, right? So this block to block transfer, this 10 registers data you want to move to 10 sequential registers, right? For that we need to write a rung like this, right? So same thing, the block format only we are going to write. The block format only you are going to write, right? So same thing, this one is the positive rail, this one is the negative rail, right? So what is this one? How many bytes of data you want to transfer? 10 register location data. What is the length of this particular block? 10 registers. 10 register data you want to move to the 10 other registers. So right, so block transfer, that length is going to be 10. Length is going to be 10, right? What is the source end? Holding register 0059. What is the destination end? 0059, right? So source end we need to write holding register 0049, destination end holding register 59, right? What operation you want to perform? That prefix you need to write here. Block transfer, BT. Block transfer. So this is once again, this gives some address. This all operation is going to perform whenever you enabled. Right? For enable, we need to give some input. Right? So whenever input, normally open contact, whenever you give input enable I, then this particular operation is going to be takes place by taking this particular prefix block transfer. Block transfer is used to transfer some bunch of registers from source to destination. Some bunch of sequential location data will transfer to some bunch of sequential location in the destination end, right? Source end to destination end, data will takes place. This length is going to be depending upon the what, how many register data you want to transfer. Here 10 register data you want to transfer, that is the reason length here you given 10, length here you given 10, you write here, right? Length is here is 10, source end is 49, destination end is 59. Whenever this block transfer is studied from this particular rung, right, after enabling, if you enable, then you look into the what operation it has to perform. Then it is look into the how many bytes of registers data. That means what is the length of this particular block. Then what is the source end, what is the destination end. So by the end of execution of, that means by the end of transfer of 10 register data transfer from source place to destination, this output is going to be high. Up to that time, this output is going to be low only. This output is going to be low only, right? That means what? So one by one register, it's going to be transfer. This data will move to here, this data will move to here, this data will move to here. Like that, by the end of 10 registers data, this output is going to be high, right? So when this is going to be executed like this. First you need to enable the input. Once enabled, then look into the what operation it has to perform. Block transfer it has to perform. That in this block, how many registers are there? 10 registers, right? So what is the source end? What is the destination end? By looking into this 10 bytes of data, that means 10 register location data will transfer to 10 other registers. By the end, this output is going to be high. Up to that time, this output is low only. This output is low only. Like this data transfer will take place. So right, to perform this block transfer, this is the rung. This is the rung. Previously, to perform register to register transfer, we have written some rung. Now block to block, this is the rung, right? Then third one is the table to register transfer. Table to register transfer, right? So third way of data transfer is what? Table to register transfer. Register transfer. How this particular operation is going to take place first, then we'll see the rung, right? So what is, for example, some table of registers are there, right? So some table of registers are there, all right? This is the table, right? So table of registers from holding register 0030. This one is the holding register 31, 32, 33, 34, holding register 0035. So like that, some table of registers are there. In this particular table, right, 4 registers data, right? This is the table. In this table, in this bunch of registers, right, this table of 4 register data, I want to move to the one register, one destination register. For example, this is the 0070, right? I want to move this particular table of 4 register data, one by one register data to this particular destination register. In the first step, I want to move this particular register data. In the second step, I want to move this particular register data, and third step, I want to move this particular register data. In the fourth step, I want to move to this particular register data to the destination register. This one is the destination register, All right. This one is a source table. This one is a source table. This one is a source registers containing you call as a table of 4 registers. In this example, you consider 4 registers. All right. In the first step, this is the step. For every step is the first step, and this one in the second step, and the third step you want to move this one, and the fourth step you want to move this particular register data to the destination. This is the one way of data transfer, right? Some table of registered data I want to move to the destination. Right? For doing this type of operation, right, we need to write a PLC rung, right? That is PLC rung. We need to write like this. This one is the rung to transfer the data from table to register, right? Table to register. It has a 3 input contacts. In this for this particular table, anyway, you know that this one is the positive rank, this one is the negative rank, right? For this particular table, in this particular table, how many registers are there? 4 registers. That is the reason you need to write here length of 4. Right. So this one is the what is the source and register here in this particular table? This one is the holding register 00. This one is the source and register. This one is the in this particular 4 register table, holding register 0034 is the end register, right? This one is the destination register. So source and register we need to place here. Source and register, end register is holding register 0034, right? So destination end is holding register 00, not destination end. Here from source to table to register transfer, only destination register is there. What is the destination register? Holding register 0070, right? So this is the three components are there in this particular box. One is the length of table, second one is the source and register in this particular table, right? And third one is the destination register. What is the destination register, right? For this particular block, 3 input contacts are there. First one is the enable contact, right? The second one is the reset contact, right? Reset contact, right? And this one is the step input, right? So for these 3 things we need to give some input values. That means some input contact activation. All right, I 0.1, 0.2, 0.3. That means what? From the input module 0 second terminal, you are going to get the input here. From the first module third terminal, it's getting input. And first module, the fourth contact is giving input to the step input. Right. In between the source and register and destination and register, we have a pointer register. Normally, we have a pointer register here. In between, we have a pointer register. Inside, we have to write holding register 00 something 10. Right. So this pointer register is normally used to store the at what pointer this one. For example, this is the pointer. This register address is going to be stored in this particular pointer register, right? At the pointer in this place, right? At that case, this pointer address is going to be stored in this particular holding register 0010, right? We need to write here in between, right? So we'll see in the next one, right? So here, what is the prefix we need to write at the output end? Table to register transfer. That is the reason here prefix is TR. Q 0 point something address if you give, right? This is the prefix TR, table to register transfer. Table to register transfer is going to be takes place. So this is the indication. TR is prefixed to transfer table data to the register. Table data to the register. See one by one what function is going to be takes place. Whenever this input is high, this operation is going to be enabled. This operation is going to be enabled. So whenever enabled, it internally it's going to be read data like this, right? It's going to be execute like this particular instruction, right? So whenever enabled, it is going to be move the looking into this particular prefix table to register transfer prefix. Whenever it's looking into the table to register transfers, right, then it's going to be move data. How many registers are there in the table, right? What is the source end in that particular table, and what is the destination register? Then it's the 4 register table length is 4. That is the reason, right? Source end is 34 means what? From 31 onwards, holding register 0031 onwards, data transfer will take place, right? From this register, data will transfer to the destination register, holding register 0070 in the first step. This step is going to get from here, right? Here it's going to give some pulse timer input to this particular contact. That means what? With some timing, it is going to give pulses to this particular contact, right? So then what will happen? For every one input active I signal, that means for every one pulse, it is going to give step input. For every one step, data will transfer. In the first step, first register data will transfer to the destination. The second step, second register data will transfer to the destination register, right? In third step, third register data will transfer to the destination. The fourth step, the fourth register data will transfer to the destination. By that time is the end of total length. That means total table transfers will take place. Transfer will take place by one register data to the same destination register. At the end of table, source and register, right? This is going to be high. This output is going to be high. That means what? After total transfers of 4 register data from one by one with every input step getting from this particular contact, right? At the end, this is going to be high. This is going to be high, right? So what is this one function? For example, reset. This is contact is used to reset. For example, after data transfer of first register data and second register data, if you want to reset, you can reset. Once you reset, once again it's come back to here. Once again it's come back to here, right? From there, once again by the next step, data transfers from will take place from this register to this register, right? So this is used to reset. What is the use of reset? Reset to back to first register, right? This enable in contact is used to enable this particular data transfers, right? This step contact is used to give step. For each step, each register data will transfer from source to destination, right? So like that, data transfer will take place from source table to destination register, right? We will see now the second way, that means what? The reverse way. That means this is the table to register transfer. The fourth case is what? Register to table. That means what? Now data transfer, it need to be performed from source. Source is the one register, destination is the sequence of tables, right? For that, how data transfer is going to be takes place, right? Now we are going to be look into the register to table transfer. Now what? This one is the source. Register is the reverse operation. Previously whatever we discussed is the table to register transfer. Now register to table, right? So now source is the register. This is the source register. Holding register, for example 0070 is the source register. This one is the destination table. Now transfer is what? Source register, holding register 72 to table, table. Now is the table is what? This one is the table. Table of registers is how many registers? 4 registers. 4 registers. That is from holding register 00312 to now data transfer will take place like this. The first step, the register data, source register data will move to the first register. In the second step, the source register data will move to the second register. Now in the third step, source register data will move to the third register of the table. The fourth step, source register data will move to the fourth register of the table. This table is 4, for example, if you consider. Right. So now what is what? Register to table transfer. In each step, source data will move like this. To perform that particular operation, this is the rung we need to write. Right. So what is the rung? Once again, length is 4. So prefix here is now register to table. Once again I am writing here. Register, RT prefix means what? Register to table data movement. Right? Data transfer, right? Register to table. Right? Prefix I written here. Previously TR, table to register. Now RT means register to table data transfer will take place. So in the similar way, here also we need to write length is 4. Once again, table has a 4 registers. Now what is now source register? Source register, not source end. Right? Source register is what? Holding register 0070. Right? So pointer is we need to write. Previously we need to written outside, but this is the way you need to write. Alright. So now destination end is, this is the table. Destination is the table. That is the region. Destination end is what? Holding register 0034. Right. So I changed little bit. That means source. Previously source is the table. Now source is the register. Previously destination is the register. Now destination is the table. Reverse transfer. Similar way. How this particular it is also as a 3 contacts. First contact is the enable contact. Second contact is the reset contact. Third contact is the step contact. Once again, whenever this input is high, this contact input is high, then what will happen? This operation is going to be enabled. Once this operation is enabled, it is going to look into this particular prefix. Right? What it has to perform. Some register data it want to transfer to the table. Right? Then how many registers are there in this particular table is looking into the value here, length of the table. Then source register. What is the source register? That means from what register data transfer need to be performed to the table. Right? So table is the next one is the table end register. Right? The first step, for example, in the first step here, the data will move from source register to the first register in the table. By the second step, same register data will move to the second register of the table. The third step, for this particular to this particular contact, getting through first module fourth terminal. I 0.3 means what? First module fourth terminal. Right? For that terminal we need to connect to the one pulsating signal. That may be from counter, that may be from timer. Alright, pulsating timer. So for every one input, like this data transfer will take place. By the end of 4 steps, this register data will move to the one by one register of the table. Right? The end of the fourth register data transfer, this one is going to be high. Up to that time this output is low only. After transfer of this source register data to the sequential location of the 4 register present in the table, this output is going to be high. Right? So this pointer register is always going to be present the address of the pointing register. This is the way data transfer will take place from register to register. Right? Second one, block register to block registers, and third one table to register, and fourth one register to table data transfer. That is by the end you can complete this. You can we completed this particular data transfer instruction. These are the 4 types of data transfer instruction. You can use this particular rungs while writing the program for any process, right, depending upon the requirement.